Up until now, all of the numbers we have been dealing with have been positive numbers, but we know that negative numbers can exist and we need a way to represent them. The first way I'm going to go over is the sign magnitude method. With the sign magnitude method, let's say we have some 8-bit number. And with this 8-bit number, we are going to allocate the most significant bit as an indicator of whether our number is positive or negative. So if we have a 1, that's going to be an indication that our number is going to be negative. If we have a 0, that's an indication that our number is going to be positive. So we're really breaking up the bit. So this most significant bit is different than the other 7 bits that we have. And we have to be able to then only represent numbers that can be represented with 7 bits. Well, in a 7-bit number, that means we can represent numbers from a minus 127, and that would be if all of our bits were 1, so we have 8 ones. And we can represent up to 127, and that would be if our first bit is 0, because the 0 means we're positive. So it's really a positive 127. And then all the rest of our numbers are 1. So it's a very simple way to represent negative numbers. In this case, this example that I had drawn right here, what is this? Well, in this number, this means we have a negative number, this most significant bit. And then what is this number that we have? So here's a 64-bit, 32, 16, 8, 4, 2, and 1. So we're going to have 32 plus 16 plus 4 plus 2 plus 1, 48, 52, 54, 55. So right here, we are representing the number minus 55 in decimal. Now, it's very easy to represent numbers using sign magnitude, but we don't really use it in computations because it's harder to compute with that. For example, let's look at this number right here. With this number, 1, 0, 0, 0, 0, 0, 0, 0. What number is this? This is a minus 0. What about this number? This is a positive 0. So 0, there is no negative in positive 0. So from a computation standpoint, sign magnitude is harder to implement. And we use different ways. We use different approaches for computation. But it's very easy to represent numbers. So let's look at this. If you're ever taking a digital logic class, you might be asked to represent a number using sign magnitude. So let's look at 87. We want to express this as sign magnitude. So what I'm going to do is I'm just going to write all my multiples of 2 to keep track of my bits. Over here, 16, 32, 64, and 128. Now, sign magnitude, we know that this 128 right here is going to be a 1 or a 0 based on if we're positive or negative. In this case, this is a positive number. So 100, my most significant bit is going to be a 0. And now we just have to convert this number to binary. So to convert it to binary, we're going to take an 87 and we're going to subtract out the biggest number that goes into 87, which is 64. This is a 23. That's my remainder. So we use 64. 32 is greater than 23, so we're not going to use 32. 16 is less than 23, so we can subtract out a 16 and we have a 7. 7 is less than 8, so we're not going to use an 8, but we can use a 4. We get a remainder of 3. 2 is less than 3, so we can use a 2. We get a remainder of 1. And 1 is equal to 1, so when we subtract that out, we get a remainder of 0. So we can represent 87 using sign magnitude notation as a 0, 1, 0, 1, 0, 1, 1, 1. Now let's look at this number right here, minus 117. we're representing a minus, so we know our most significant bit has to be 1. But then we're going to use the same steps to figure out the rest of our binary numbers. So we're going to have 117 minus 64. This is 53, but we use the 64, so we subtract out 32. This is going to be 21, so we can subtract out 16. This is a 5, so we cannot use an 8. An 8's bigger than a 5. We can subtract out a 4. And let me just move this down just a little. So we used a 4. 2 is greater than 1, so we're not going to use a 2. So when we subtract out our 1, we get a remainder of 0. And this is our binary number to express negative 117 in sign magnitude form. So 1, 1, 1, 1, 0, 1, 0, 1. So hopefully this gives you an idea of one way that we're able to represent negative numbers using binaries notation in sign magnitude form.